Welcome to aminacademy.com. In numerical methods and analysis, let us discuss about Newton's Raphson method for solving algebraic equations. Here, to find the root of an algebraic equation by defining a sequence of numbers that become successively closer and closer to the root sort. This method is best illustrated in graph here. Here, this x and y line is there, and that a graph of f of x is drawn. First, find the tangent at a point A, which is x of 0 and f of x 0. Draw a tangent. Let the tangent line let meet at the point at x1, and from the tangent from the point x1 draw a perpendicular line which meet a curve at point B. That points are x1, f of x1. Through that point draw another tangent. Let the tangent meet at the point x2. From that x2 draw a perpendicular to x-axis. Let it meet at point C, where the points are x2 and f of x2. Like this, we have to go continuously, draw a tangent and get a, from that we can get the root of the equation. Let S be the actual root of the equation f of x. Let S be the actual root of f of x equal 0. Now we define that points A, B and C. Now slope of the tangent line from first point, the point x0 and f of x0 is 0, 0 minus f of x0 divided by x1 minus x0. Then here, therefore this we know the slope of the function f of x is f dash of x equal minus f of x0 over x1 minus x0. Then by cross multiplying, that is x1 minus x0 equal f of minus f of x0 over f dash of x. Now from that, x1 equal x0 minus f of x0 over f dash of x. Similarly, x2, the point x2 is x1 minus f of x1 over f dash of here 0, f of f dash of 0, here 0, here x1. Now in general we can write the recursive formula f x n plus 1 equal x n minus f of xn over, not full over, it is over f dash of xn. That we start with a given value of x0, we can obtain x1, x2, x3. So given value of x0, we can find the value of x1, x2, x3 like here. This is the general formula for finding the root for Newton-Raphson formula. Note the point here. If f dash of x is very large, that is when the slope is very large, the correct value of the root can be found with great rapidity, because its greater value of f dash of x means it come to the perpendicular easily. So it is easy to find the root. That means quickly you can find. Then second, the process will evidently fail if f dash of x equal to 0. Third, if we choose the initial approximation x0 close to the root, then we get the root of equation is very quickly. Now, next note, if modulus of f of a is lesser to modulus of f of b, then a is taken as the first approximation. Let us write the notes here. First one, when f dash of x is large, that is slope is very large. This slope is very large, then we can find rapidly the root. We can find the root rapidly because it comes to, that slope comes to perpendicular easily. Then second, if f dash of x equal to 0, f dash of x 0, then the formula fails. It fails. Means this formula fails. Third one, you have to choose x0 which is close to the root, closer choose the initial approximation f0 which is closer to the root. Root means we are assuming the roots. Fourth one, if absolute value of f of a, that is chosen value, f of a and b are chosen values, is lesser than f of b, then a is taken the first approximation. Taken the first approximation. Otherwise, if f of b is lesser than f of a, then b is closer to first approximation. Now, fifth one, this method is called method of tangent. This is called method of tangent because we are using the tangent, drawing tangent and finding the values. We have done. Please subscribe our YouTube channel.